Howdy and welcome to my part 2 video for functions. Today I'll be doing practice problems from the Virtual Math Learning Center, whose link to these problems will be put in the description. The content for today will be specifically about analyzing graphs of functions and parent functions and their transformations. Okay. I'll be going through these practice problems, talking about my thought process, the work, and of course, reviewing the concepts themselves. So, for question 1, we have this graph here, and we define the following function values. The first thing I'm going to do is that I'm going to make the axes more visible to myself. This way I can more clearly spot the origin. Okay. So the origin's about right here. Okay. So you want f of -1. So we'll do this is -1. Okay. I have an f of 2, which is right here. And an f of 4, which is over here. Let me circle this actually. Sorry. Yeah. There you go. Circle enough. So for f of -1, so our x will go up, right? And we see that is at y equals 3. So function value is 3, okay? For our f of 2, we can see that it's actually on top of an open circle. And for an open circle, it means that there is no defined value for the x value. So our answer is does not exist. And then for f of 4, it's actually outside the bounds of the graph, right? The bounds of the graph are from what seems to be -3 to 2, right? Like if we were talking about domain, our domain is -3, 2, inclusive for -3, exclusive for 2. 4 is outside, so it does not have a solution. So it too will be does not exist. And that is question 1. Okay, so question 2 is asking whether function is even, odd, or neither. So as a recap, let me highlight this. An even function, right? Even is defined where f of x equals, f of -x, my apologies, equals f of x. So even if you take the opposite of your x value, you end up with the same value, okay? And this allows you to have symmetry about the y-axis, right? And it makes sense logically, right? If you take an x value somewhere, right? If you take this x value and you flip it, and you have the same y, they would be symmetrical about the y-axis, right? Now for odd functions, if you do f of -x, you actually get -f of x. And this is what we call symmetry. I need to move this a little down. This is what we call symmetry about the origin. Okay, move this arrow. So if you graph this instead, so you have a point right here, right? So you're gonna have a point at opposite like this, right? And you can see that they make this really nice line for the origin like this, and it's symmetrical both the x and the y, right? it's flipped both this way, right? So the y, and this way, the x. And that is centered around the origin. Okay. Now, if neither of these conditions are met, then it's neither. There's no symmetry. Okay. Well, it's not necessary that there's no symmetry, but no, yeah, there's just no symmetry. Sorry, yeah, there's just no symmetry. So part A, right? So our test is to put in negative x, right? So f of negative x, and we'll just put in a negative x where we see x, right? So negative x times the cube root of negative x to the fourth plus 1. This gives us negative x cube root x to the 4. Because a negative raised to an even power just cancels out to a positive, right? Plus 1. And you can see that if I highlight our original function in pink, or it's pink, right? And I write, you can do this. And you can see that our original function shows back up. And this is simply negative f of x, right? So this is odd. And the symmetry is, I'm going to do shorthand, about y-axis, okay? About the origin, yeah. That is the first one. Now for part B, I'm going to put in negative x. So g of negative x equals negative x to the fourth minus 9 over negative x to the fourth, to squared, sorry, plus 9. And this is equal to x to the fourth minus 9 over x squared plus 9. And you see that, again, I'm going to highlight our original function. We get the same function again. So it's equal to itself, right? With normal x. So this is even of symmetry about the y-axis. For part C, we'll plug in negative x into h, our function h here. We get negative x cubed minus 3x squared. And we can simplify, oops, sorry, negative x squared. And we get negative x cubed minus 3x squared, because negative times negative is positive, right? And we can see that our function doesn't show up at all, right? In its current state, it's not equal to function. And if we took out negative, right, we get x cubed plus 3x squared. And this inside part is not equal to h of x, right? And this right here is also not equal to h of x. That means we don't have any symmetry, and this is, or it's not odd or even. So this one is neither odd or even. And that is question 2. All right. So for the next question, we'll be looking at this graph, and we need to identify the parent function. We need to describe a sequence of transformations from f to g, so from the parent function to the graph. Find what g is, and then use function notation to write g in terms of f. Okay. So your parent function, right? Your parent function tends to be it's like f of x to some power. There are other special ones like f of x equals the absolute value of x, right? I believe there's f of x equals there's log x as well, I'm pretty sure. And there's one for natural log of x, right? But you can treat, log and any sort of log, right, itself as a function. So that would be a parent function of itself, right? But if we look at this graph, right, and we see this unique, U shape, right? There's only one function with a U shape. This distinct U shape belongs to x squared. Okay. You just have to memorize this. So like x, right, is this linear. X squared is a U shape. X cubed is this funky little thing, right? So we know that our parent function should be x squared, right? It's definitely not absolute value, because absolute value looks something like this. And I think natural log, natural log and log are very slow, so it's kind of like this. It's also positive sided, right? So our parent function, and this is something you just have to remember, right? Our f of x will be x squared. That is our first answer. Okay. Now part B is to describe a sequence of transformations. Now first off, this is upside down, right? So our first transformation is our reflection, right? So you flip it to reflecting, right, over the x-axis. Because we're taking this shape and we're reflecting it across to get this upside down shape. Okay, so that's our first transformation. And now we note that the origin is like right here, right? And I'll make these axes a little more clear. Draw that. There's that. Oh, that's the really stands it. That will work. Okay. So the next transformation to note, right, is that shift of the origin, right? Because these functions, like this y squared, right, it's centered at the origin. Well, it's moved, right? So, this is its current, the peak, right? That bottom or top of the U shape tends to be at origin, but this time it's moved. So we can see that from here to here, right? Going here is left 3, right? And from, let's see, red, here to here, it's up 4, right? So I have 2 more transformations, which is, we can say up, right, which is a horizontal translation, sorry. Wait, sorry, not up, left. Right, by 3 units. And then we're going up, right, to a vertical translation. Of 4 units, right? So if you're using horizontal vertical translation, right, note that if you're going to the left or you're going down, right, it's going to be a negative number, right? So this would be negative 3 units. And this gives you plus 4 units. Okay. Now that's not it, right? We need to check if like the stretch, like did we widen it or did we shrink it, right? So I'm gonna assume, so we know that with these reflections so far, right? We currently have g of x, right, equals x plus 3, right? Because we could do minus negative 3 squared plus 4, right? So x plus 3 squared plus 4. But the thing is, this assumes that we didn't stretch it this way and this way, or we didn't shrink it up and down, right? So we have to make sure that the points are where it should be. So you see right here, right? So if this is the origin, right? Sorry, let me do this way. So we have this, right? And we have some coefficient k, and this is our like stretch coefficient. I mean, this is the easiest way for me to explain this. Right, there's a stretch coefficient. It's like when you're doing, you're trying to find the equation of a graph, right? There's a k leading term you have to figure it out, right? The stretch coefficient, and you figure it out by plugging in a point, right? You plug in like the peak here, it doesn't really help, right? Because that stays still no matter what. So you want to choose a point that's not the minimax, like this one. This one is at -1, 3, right? So we'll do 3 equals k times -1 plus 3 squared plus 4. -1, so I'm just dealing with this 4, okay? Equals k2 squared. Sorry. And then, oh, actually, let me do something real quick. Because of this reflection of x-axis, right, there's a negative right here. So it should be negative k, okay? Negative k. And yet, -1/4, right, equals negative k. So k equals 1/4. So with this k 1/4, right, since I solved it for outside, right, when I solve the k for outside, this is actually, when k is outside, this is for vertical stretch. Okay, so our k, right, this k is less than 1. K is less than 1, which implies that we have a shrink. So our last transformation is vertical shrink. And I don't remember the proper terminology for that. By a factor 1/4. Right. Now, if k was greater than 1, right, you get a stretch. Okay, so this would be my answer for part B. So all the transformations, right? The sequence, right? You want to kind of deal with y first, if any x, just to make sure that everything is a-okay, right? So these translations should go last. Let me take this box out. Okay. Oh. So I believe what you should do first, right, is you can reflect, right, and then you can stretch, because that's completely fine. The order of these two won't really matter too much. And then you do your translations. Now order does matter, okay? Because, and I'll show you in a bit here, okay? Order does matter because of these steps, okay? Actually, these 3 y steps right here. So I said that we started with f of x, right? And if we go in order, right, reflection across y is negative f of x. And then a shrink, right? So negative 1/4 f of x. And then left 3 gives you this. And then up 4 gives you this. Plus 4, right? Now, if you did it earlier, right? So like, I think it was reflection first. And then I went left. And then I went up, right? Now, when I do the 1/4, right? I do the whole thing, right? So it'll be 1/4 the entire thing, which gives me something a bit different, which is negative 1/4 fx plus 3 plus 1, right? Because I am shrinking everything in the y, okay? This is why the order does matter. Shrink and reflection don't really care too much, but yeah, this is the order I write in. Okay. For C, I kind of already did this, right? G of x, and we'll just do our transformations, right? Negative reflection, 1/4 shrink, and then we have left to the 3, it's squared, right? Because our parent function, we had 4. And then for part D, right? So remember the f of x, like I said earlier, is x squared, right? So we're going to go through the same process I just showed, right? So we have, so after the first step, right, we get negative f of x, and then it becomes negative 1/4 f of x, and then it becomes negative 1/4 f of x plus 3, and then it becomes negative 1/4 fx plus 3 plus 4. This means my g of x, right, now is negative 1/4 f of x plus 3 plus 4. That is part D. All right, so for question 4, or I guess 2, right? We have this function again, or not again, but we have another function to consider, and we need a parent function, we need a sequence of transformations, and we need to write g in terms of f. So for part A, right, we know that a lot of times, or most of the times, a parent function is x to some power. The square root is present, so I'm going to assume it's going to be the 1/2 power, or just square root. And if you do remember your parent functions, square root x is indeed a parent function. Okay. Now for part B, this is where it gets interesting. So it wasn't really in part in the previous question, right? There's only one transformation in the x direction, so that was easy. But now we have 2, and the order gets a little convoluted. Let's first talk about the y direction, okay? For the y direction, I am first going to reflect across the y-axis, not reflect, we're going to stretch by 2. So vertical stretch by a factor of 2. And that gives us this guy right here. And then we go down 4. And that gives us the negative for the end. Now, the problem is, what do we do about this inside part, right? So, let's see. Okay, so for the x direction, we have this negative x plus 3, right? So we can rewrite this as, oh, this is negative of x minus 3, all in parentheses, right? But now you would think, oh, we would do this transformation first, and then the negative, right? This is wrong. For x, everything's flipped. So you actually go in reverse of the order of operations. So this is actually your first operation, and then this is your second operation. Okay? So in that case, we have reflection over the y-axis. And then we go right 3 units. Okay. But then there's the other tricky part. Okay. You have negative x plus 3, right? But you know that it came from x in the start, right? So if you think of x, you can go from x to this by, you can go left 3 first, and then place a negative sign. Right? So in this case, you actually go left 3 first, and then you reflect over y-axis. This might be more straightforward to people to do this translation first and then do the negative separately. But if you take the negative out like this, you have to do reflection first, followed by the translation. These are some, it's a bit of a tricky question, okay? And that means our answer, right, we can have this thing here, followed by our first way of doing the x. First way doing x, or you can do the y again, same way, but the other version for x. Both are equally valid answers. So you use the same function. Okay. For part C, we need to rewrite g in terms of f, right? So the square root is a function, right? So you can just say, you can replace the square root of f essentially. So g of x will equal 2 times the square root, which is f, right? X plus 3 minus 4. Negative x plus 3, sorry, right? And that would be your answer. If you went through the steps one by one, you also get the same thing. So for the first version here, right? So f of x, then you get the vertical stretch by 2, so 2 of f of x, and down 4, so you have 2 f of x minus 4, right? So let me color code. So this is 1, this is 2. You do the way 1 goes, you would get 2 f of negative x minus 4, which is followed by 2 f of negative x minus negative, x minus 3 minus 4, which you do the same equation of negative x plus 3 minus 4. Or you can just translate first. Do 2 f of x plus 3, right, minus 4, followed by 2 f, and then you just flip the x, right, plus or minus 4. So each of these only affect the variable itself, right? So the minus 3 affects just the x, right? And this negative translation, only the x. All right, and that is it for this video.